So for the first one, 27 plus a negative 42, what'd you get? Negative 15 works for me. Number 2, negative 43 minus 18, what'd you get? Negative 61 works for me. Number 3, negative 11 times 7. Negative 77. Number 4, negative 48 divided by negative 6. 8, good. Number 5, 23 minus a negative 34. 57. And finally, negative 18 minus a negative 27. 9. Okay. Any questions on those? Okay, out of the book, we had pages 111, 114, and 116. Any questions? Let's start on 111. Any questions on 111 that you want me to go over? Okay, where we usually get a lot of questions is starting on 114 with the subtraction. Any questions on 114? Okay, how about 116? Which ones did you want me to go over? 51. Okay. Did we end up with word problems on this one? I don't think we ended up with word problems here. Okay. Most of those on 51 through 79, we're looking at dividing or multiplying. Most of those are division. And it's just keeping track of the sign again. So something like 71, we have negative 49. They just use the parentheses to make sure the negative goes with the number. Divide by a negative 7. All you have to do is a negative divided by a negative is going to be a positive. 49 divided by 7 is 7. So you can divide the numbers and treat the signs separately almost. Well, actually, not almost. You can treat the signs separately completely. It's like 79. Yeah, negative 96 divided by negative 12. Same thing. A negative divided by a negative is going to give us a positive. 96 divided by 12 will be 8. Now, has everybody figured out how to enter negatives in their calculator? Anybody not sure how to do it on a calculator? Okay, so we are about to take a quiz. On this quiz, I believe it's going to be the first 6 problems. So questions 1 through 6. I want you to show the work. So either on the back of the page or beside the problem somewhere, show the steps. If you need to use your calculator to double check it, or need to use your calculator to combine digits, that's fine. But when I say show your work, if I have something like 27 times 43, you need to show out 7 and 3 is 21, carry the 2. That's 6, that's 8. 0, 8, carry the 2. That's 8, that's 10. You need to show all the steps like that on those first 6. Okay? So I'll pass out the quiz here in just a second, and we'll get. So our new stuff for today looks like this. (17 minus 3 times 5 plus 8). Now, when we have several things, several operations like this, there are a lot of different ways this problem could be interpreted. Some would say, well, we read from right to left, so I would just start on the right and work my way to the left. But that would give you a wrong answer. In math, we like to have 2 people look at a problem and get the same answer. So to make sure that happens on a problem like this, we have defined something called the order of operations. Now, the order of operations only applies when we have a situation like this where it's a bunch of operations and numbers with no story or no context behind them. Most of the time, there will be a context. A lot of the problems you guys do will be word problems. The situation itself will define what order the operations have to happen in. So the order of operations only applies when it's just numbers and operation symbols like this. A lot of people mistakenly think that the order of operations is a set of steps, and that's not quite correct. What the order of operations is levels of priority. Certain things have higher priority than others. So if there's two things that are going to happen, whichever one has the highest priority has to happen first. So the highest level of priority is something called enclosing symbols. Many of you have probably heard this one is just defined as parentheses. And parentheses and its various forms are one of our enclosing symbols. Parentheses, brackets, the squiggly brackets and square brackets and all that stuff are all just forms of parentheses. But there are other types of enclosing symbols that we will run into. Second, after enclosing symbols, the next highest priority is something called exponents. Exponents include powers and roots. As we move on to the semester, we will learn that exponents and powers and roots are just like our other operations. They're inverses. Our operations come in pairs, like addition and subtraction work together, multiplication and division work together. Our powers and roots work together as well in the same way. Third, next down in our level of priority, is the multiplication and division. And then finally, the lowest level of priority. The last thing that would happen as we're working with numbers is addition and subtraction. Now that doesn't mean addition and subtraction can't happen before any of the other operations. It can if something in our levels of priority says it should. And we'll see examples where that happens as we go through the rest of the class here. So back up to our original problem here. Do we have any enclosing symbols? No. Any exponents? No. Multiplication or division? Yes. So that's the first thing we have to do. We only have the one multiplication here, which is 3 times 5. So what we're going to do is we're going to take out the 3 times 5 and replace it with the result, which is 15. You got it. And the rest of the problem does not change. Everything else stays the same. Now from there, we're down to addition and subtraction. Addition and subtraction are both on a level 4 priority. So if they're on the same level, then we do work left to right. So we're going to do the 17 minus 15 first, which is 2. Again, the plus 8 is still there. 2 plus 8, 10. So let's look at something slightly more difficult, a little bit more intense. So something like this, just a touch more difficult. There are a few things going on here, but it's really not that tough as long as we break it down step by step. Now, I'll give you a warning. The biggest mistake I see people make on a problem this size is rewriting it after they do each step. So be very careful. So now as we look at this, we have enclosing symbols. In fact, we have several sets of parentheses here. So we work left to right. Going left to right, the first one we find is this one right here. Where's its other end? Is this one it? Nope, facing the wrong way. How about this one? Nope, that just goes back to this one. Down here, that's the one. So we're going to start by working inside that set of parentheses, inside the blue box, if you will. Now, inside there, our order of operations still applies. So we stay at that highest level of priority. Are there any other enclosing symbols? Yeah, there is another set of parentheses. So we're going to narrow our work down to that set of parentheses. So inside the green box. In there, are there any other enclosing? Bless you again. Are there any other enclosing symbols? No. Any exponents? No. Multiplication and division? Yes, we've got 36 divided by 9, which is 4. So I'm going to take out the 36 divided by 9, replace it with 4. Now I have to be careful to rewrite the rest of the problem exactly as it appears. So the 36 is gone, so it's the minus sign going this way that I'm going to start with. Now we're still working inside that parentheses, inside that green box. What's left to do there? 12 minus 4, which makes 8. Now, once we've reduced the parentheses down to a single number inside of it, we don't need the parentheses anymore. So I'm not going to write in the parentheses this time. There's no need for them. So in front of the parentheses, we had the minus, the 19, and so on. So now we're back out to this larger set of parentheses. We finished off the small one in the green. Now we're back out to the blue one. In there, do we have any other enclosing symbols? No. Exponents? Yes. 2 squared, or 2 to the power of 2, which is 4. So again, we replace that with a 4. Everything else stays exactly as it was. Next, inside the parentheses, any other exponents? No. Multiplication or division? There's a couple, so we're going to go left to right. We're going to do the 3 times 4 first, which is 12. Now, to be honest, if I were doing these for myself, I would actually be, especially using here where I can erase, I would actually be doing this. I'd actually, like I'm going to do 4 times 2 here. I would actually erase the 4 times 2 and write in an 8 rather than rewriting the whole problem, just because it saves me time. So if you can come up with a system like that that works, then just be very careful not to lose information. So 4 times 2 is our next step. I'm going to write in the 8. The rest of the problem does not change. Now what's next? Well, we're still inside the parentheses. All that's left is addition and subtraction, so we're going to go left to right. 19 minus 8, 11. Save a little time. I'm only going to rewrite what's inside the parentheses until we get done with it. What's next? 11 plus 12 is 23. And then 23 minus 8 is 15. We've reduced the parentheses to a single number, so we don't need the parentheses anymore. I'm going to rewrite the rest of the problem. Now there's something weird here with that 3 right in front of the 15. What do we have to do there? We're going to put in multiplication. Anytime there's a number outside the parentheses without an operation between them, it's implied to be multiplication at the beginning or the end of the parentheses. So now we're done with that set of parentheses. Any other enclosing symbols? Yes, over here. 3 plus 5 is 8. Now there's no more enclosing symbols. Are there any exponents? No. Multiplication and division? Yes. 3 times 15 is 45. Now we're down to addition and subtraction. We're going to go left to right. 5 plus 45 is 50. Plus 8 is 58. So we get an answer of 58. Now that's a lot of work, right? Yours won't be quite that long, I promise. Another type of problem we can run into might look like this. So when we look at a problem like this line, bless you, first thing we have to do is figure out what this line across here means. What does it mean? Okay, division. Most people say division. It's called a fraction bar, and it does mean to divide, but it is also an enclosing symbol. It separates the top from the bottom. So what it's telling us is we have to do everything on top first, then everything on bottom, and then we can divide. So let's do everything on top first. I'm going to have to rewrite that over here so I can work on it. What part do I have to do first here? The exponent. The 2 squared, which is 4. So next is multiplication and division. We're going to go left to right. 7 times 8, 56. 32 divided by 4, 8. So 56 minus 8 is 48. So the top of this is 48. Now we have to do the bottom. On bottom, what do we have to do first? Exponent. 5 squared is 25. Perfect. And then 9 times 4 is 36. And then 36 minus 25 is 11 plus 1 is 12. So the bottom is 12. Now we can divide that out. 48 divided by 12 is 4. Now, a little bit of a warning. If you're going to do this first one up here on your calculator, as long as you enter it exactly how it looks there, your calculator will do it. Some of your calculators, when you do a power like 2 squared, like on mine, I do 2 to the power of 2. Notice the cursor stays up there. You have to do a little down arrow to get it out of the power. Or a right arrow, depending on your calculator. Mine apparently is a right arrow, not a down arrow. But you've got to use your arrow to get out of the power before you type in the rest of the problem. So be aware of that as you're working on them, that you have that. But otherwise, if you enter this problem in exactly as it appears here, your calculator actually does the order of operations correctly. This one down here with the fraction bar can be pretty tricky to enter in the calculator. So what I would recommend you do there, enter in the top and get an answer like we did, then type in the bottom and get an answer like we did, then divide the two numbers. Now this next one is going to stretch our operations that we know so far, but I want to go through this one anyway. Looking at this one, what's this symbol here? It's a square root. It can also be an enclosing symbol. A square root is an exponent, but in this case, it's an enclosing symbol as well because it separates part of the problem from the rest of it. So just like a parentheses, we have to do everything inside there first. So inside there, what has to happen first? 3 squared, which is 9. What's next? 7 times 9 is 63. And then 1 plus 63 is 64. Now that we have what's inside the enclosing symbol, in this case, what's inside the square root, down to a single number, we can get rid of that enclosing symbol, just like with parentheses. The difference is with parentheses, you just took out the parentheses. You maybe had to put in multiplication. For square root, you actually have to do something. Square root of 64 is 8. Now, just like with the parentheses, the 3 is there. What operation is implied? Multiplication. So 3 times the 8. So then next we have to 3 times 8, which is 24. And 9 plus 24 is 33. Any questions? You also have an absolute value symbol. That absolute value symbol, what that means, remember we talked about those vectors on the number line. That is asking for the length of the vector. It's also an enclosing symbol. We have to do everything inside it first. 3 minus 9 would be -6. The length of the vector for -6 is 6 units long. I'll let you guys have the last 6 minutes here to get started on the homework. On page 13 and 14 in the book, problems 1 through 41, the odd. Make sure you're checking those over yourself. And again, if the first few are easy, feel free to skip ahead and do the more difficult ones.